crucial as it determines the processor type on which you want your pods to run. Hello and welcome to this lesson on prerequisites to configure cluster with virtual nodes. I am Mahendra Mehra, your senior OCI instructor at Oracle University. So let's get started. Let's discuss the required IAM policies for using virtual nodes. And these policies are crucial for both tenancy administrators and non-administrator users. Let's jump into the specifics. Before you can use virtual nodes, you always have to set up at least one IAM policy, which is required in all circumstances by both tenancy administrators and non-administrator users. This basically means to create and use clusters with virtual nodes and virtual node pools, you must endorse Container Engine for Kubernetes service to allow virtual nodes to create container instances in the Container Engine for Kubernetes service tenancy with a VNIC connected to a subnet of a VCN in your tenancy. So all that you need to do is create a policy in the root compartment with the following policy statements exactly as shown on the screen. You can copy and paste these policies from the official documentation page, and you will find them under the Working with Virtual Nodes section within the Container Engine topic. So you just need to copy these as it is and paste it in the root compartment of your tenancy. Now let's move on where we'll continue discussing the necessary IAM policies for using virtual nodes. Pay close attention, especially if you are a non-administrator user looking to utilize virtual nodes. For a non-administrator user, these are the policies that must be in place for them to actually work with virtual nodes in a Kubernetes cluster. These policies allow the non-administrator users to manage cluster virtual node pools, to read virtual network family, and to manage VNICs in compartment. The same is also available in the official documentation. You can simply copy paste these policies from the official documentation page. Let's head back to our slide. We are going to explore the creation, configuration, and network setup of virtual nodes and virtual node pools. Let's start by focusing on the creation process. Creating virtual nodes is a pivotal step and it involves setting up a virtual node pool in a new cluster, and this is exclusively applicable to enhanced clusters. You can initiate this process using the console, the CLI, or the API. Now let's shift our focus to the configuration aspect. Configuring your virtual node pools involves defining critical parameters. Firstly, we have the node count. This represents the number of virtual nodes you wish to create within your virtual node pool. These nodes will be strategically placed in the availability domains that you specify. Now, it's important to carefully consider the placement of these nodes. You can distribute them across different availability domains, ensuring high availability for your applications. Additionally, you have the option to place these nodes in a regional subnet, which is the recommended approach for optimal performance. Moving on to pod shape. This refers to the type of shape you want for pods running on your virtual nodes within the virtual node pool. The pod shape is crucial as it determines the processor type on which you want your pods to run. It is important to note that only shapes available in your tenancy and supported by Container Engine for Kubernetes will be shown. So choose a shape that aligns with the requirements of your applications and services. A noteworthy point is that you explicitly specify the CPU and memory resource requirements for virtual nodes in the pod specification file. This ensures that your virtual nodes have the necessary resources to handle the workloads of your applications. Precision in specifying these requirements is key to achieving optimal performance. Our last stop is the network setup for virtual nodes. Now let's talk about pod communication. The pod running on virtual nodes utilize VCN native pod networking. and it's crucial to specify how these pods in the node pool communicate with each other. This involves setting up a pod subnet, which is a regional subnet configured specially to host pods. The pod subnet you specify for virtual nodes must be private. Oracle recommends that the pod subnet and the virtual node subnets are the same. In addition to subnet configurations, you have the option to use security rules in Network Security Group to control access to the pod subnet. This involves defining security rules within one or more NSGs that you specify, with a maximum limit of 5 network security groups. Also, it is worth noting that using network security group is recommended over using security lists. Now let's shift our focus to virtual node communication. For this, you'll configure a virtual node subnet. This subnet can be either a regional subnet, which is recommended, or an availability domain specific subnet, and it's designed to host your virtual nodes. Considerations for virtual node subnets: if you've specified load balancer subnets, ensure that the virtual node subnets are different. As with pod communication, Oracle recommends that the pod subnet and the virtual node subnet are the same, with the added condition that the virtual node subnet must be private. To wrap up, in this lesson we covered the key prerequisites for configuring an OKE cluster with virtual nodes. From essential IAM policies to fine-tuning node and pod configurations, we emphasize the critical role each element plays. The network setup, ensuring seamless pod and virtual node communication, adds the final touch. Remember, meticulous attention to these prerequisites sets the stage for a resilient and high-performing cluster environment. I hope you found this lesson useful. See you in the next one. Thank you so much for watching. Hello and welcome to this lesson on virtual node and node pool management and resource allocation. In this lesson, we will discuss the fundamental tasks involved in managing virtual nodes and virtual node pools. Let's explore in detail. Whether you're creating a new enhanced cluster using the console or looking to scale up an existing one, the creation process is versatile. Our next task brings us to listing virtual node pools. These pools are distinctively marked as virtual in the node type column. This visibility makes it easy to track and manage your resources efficiently. For a comprehensive understanding of your virtual node pools, navigate to the cluster list page and click on the name of the cluster. This will unveil the specifics of the virtual node pool you are interested in. Now let's talk about updating virtual node pools. Whether you're initiating a new enhanced cluster or expanding an existing one, the update process ensures your cluster aligns with your evolving requirements. You can easily update the virtual node pool's name for clarity. You can also dynamically change the number of virtual nodes to meet the workload demands, and you can fine-tune the node placement using options like availability domain and fault domain settings. You can also update the communication and characteristics such as virtual node communication. You can personalize settings for subnet and network security group to enhance virtual node interactions. You can also customize the pod, subnet, and network security group for secure and efficient communication within the node pool. Optionally, you can apply Kubernetes labels and taints for greater control over node behavior and work node placements. Moving on to an essential aspect of node pool management, that is deletion. It's crucial to understand that deleting a node pool is a permanent action. Once deleted, the node pool cannot be recovered. As we navigate through node pool termination, a critical consideration is the cordon and drain process for worker nodes. This step ensures a smooth transition and minimizes potential disruptions. Cordon prevents new pods from being scheduled on a node, while draining gracefully evicts existing pods, redistributing them to other nodes. Let's explore the fundamental task of creating, listing, and obtaining details about virtual nodes. To kick things off, creating virtual nodes involves establishing a virtual node pool. It is important to note that virtual nodes can only be created within enhanced clusters. Moving on to listing virtual nodes, this task offers visibility into virtual nodes within a virtual node pool. Whether you prefer console, CLI, or the API, you have the flexibility to choose the method that suits your workflow best. Lastly, gaining detailed insights into a virtual node is crucial for effective management. To obtain these details using the console, you can navigate to cluster list, within which you can select the cluster name. You can go to the node pools in the resources section, click on virtual nodes, and from there select the virtual node of interest for comprehensive information. Let's explore the critical factors and considerations when allocating CPU, memory, and storage resources to pods provisioned by virtual nodes within your OKE cluster. To ensure optimal performance, OKE calculates CPU and memory allocations at the pod level, a distinctive feature when using virtual nodes. This approach stands in contrast to the traditional worker node level allocation. The allocation process takes into account several factors. First one is the CPU and memory request and limits. These are specified for each container in the pod spec file if present. Secondly, number of containers in the pod. The total number of containers impacts the overall resource requirements. And kubeproxy and container runtime requirements. A small but essential consideration taking up 0.25 GB of memory and negligible CPU. Make a note, pod CPU and memory requests must meet a minimum of 0.125 OCPUs and zero point 0.5 GB of memory. Let's dive into the intricacies of CPU and memory allocation rules within the pod spec when working with pods provisioned by virtual nodes in OKE. Let's take a look at the allocation rules. If a limit is specified in the pod spec but no request, Container Engine for Kubernetes will use the limit value. But if a request is specified and no limit, Container Engine for Kubernetes uses the request value. If both a request and a limit are specified, then the OKE uses the limit value. If neither a request nor a limit are specified, OKE will use 0.125 OCPU and zero point 0.5 GB per container. These rules govern the allocation process, ensuring that the CPU and the memory are distributed efficiently based on the specifications provided in the pod spec file. Considering that pod provisioned by virtual nodes always come with an assured capacity, we highly recommend setting limits and requests to the same value. This practice aligns with the assured capacity model and contributes to predictable and efficient resource utilization. The maximum number of CPUs that can be allocated to pods provisioned by virtual nodes depends on the shape specified for the virtual node pool. For instance, in the case of pod with standard E3 Flex and standard E4 Flex AMD shapes, the maximum number is 64 cores, which is 128 vCPUs. Understanding these constraints is essential for effective resource planning and allocation. Let's explore the network and storage allocation considerations for pods provisioned by virtual nodes in OKE. The number of OCPUs allocated to pods play a crucial role in determining the network bandwidth available to these pods. Specifically, there is a provision of 1 Gbps per OCPU. However, this is subject to certain limits to ensure optimal network performance. There is a maximum bandwidth limit set at 40 Gbps, ensuring that the network capabilities are efficiently utilized. On the lower end, there is a minimum bandwidth limit of 1 Gbps, ensuring a baseline level of network connectivity. In addition to network considerations, let's look at the storage allocation for pods provisioned by virtual nodes. Each pod is allocated 15 GB of storage space dedicated to storing the root file systems of containers running on the pod. It's crucial to note that part of this 15 GB storage allocation is consumed by container images. The remaining allocation is then available to the application for use as temporary storage. In wrapping up our journey through virtual node and node pool management along with resource allocation, we've looked into essential aspects ranging from the inception and modification of node pools to the precision of communication configuration and resource fine-tuning. These elements collectively contribute to the orchestration of a robust and high-performance Kubernetes environment. I trust you found this lesson useful. See you in the next one. Thank you for your attention. Hello and welcome to this demo on create cluster using default settings in the quick create workflow using virtual nodes. In this demo, I'll walk you through how to create an OKE cluster using virtual nodes and virtual node pools with the default settings and network resources using the quick create workflow. So let's get started. Well, I've already logged in into my OCI console. Let's go to the Kubernetes service. Let's click on the hamburger menu. Under the developer services, under the container and artifact section, we have the Kubernetes cluster. Let me click on it. And let's create a cluster using virtual nodes and virtual node pool. The compartment in which I'll be creating the cluster is CTD OKE and my region is US West Phoenix. Let me click on create cluster. For this demo, I'll be using the quick create workflow. That is the default selection. Let me click on submit. Let's provide our cluster a suitable name. Since this cluster will be created using virtual nodes and I'll place the Kubernetes API endpoint in the public subnet, this is the name that I've given, OKE-VN for virtual nodes. Public stands for the Kubernetes API endpoint to be in the public subnet. Let's proceed. In the compartment section, the default compartment is the right compartment where I want to create this cluster. So that's CTD OKE. The Kubernetes version is the default version that I wish to use. Now under Kubernetes API endpoint, I'll be going ahead with the public endpoint. So let's leave it default. Next comes node type. This time I'll be using the virtual nodes option. So let's select virtual nodes. Remember, whenever you select virtual nodes require a specific IAM policy, and without this policy, the pod creation will fail. As explained in a lesson earlier, you need to define these policies in your root compartment. What you can do is you can copy the policies from here and put them in the root compartment. Also, let me quickly show you where I have placed these policies. Let me duplicate this tab and let me take you to the policies page. Let's go to identity and security. Under policies, let me take you to the root compartment. If you notice, I have created a policy for OKE virtual nodes. There you go. These are the policies that you must have in place to work with virtual nodes. As you can notice, these are the set of 5 policies that you must have in your root compartment, and they are present in my root compartment. This means that I have the policies in place and I can proceed. For your information, I'm running this demo as an administrator, so I have all the privileges to create cluster resources. But if you're looking at creating a cluster using non-administrator account, then you must have the other required policies in place as discussed in our previous lessons. Under the node count, you specify the number of virtual nodes to create in the virtual node pool placed in the regional subnets created for the cluster. And remember, the nodes are distributed as evenly as possible across the availability domains in a region. And sometimes, in case if a region has a single availability domain, they are distributed across all domains in that availability domain. Under the pod shape section, you specify the shape to use for pods running in the virtual nodes in the virtual node pool. And again, the shape determines the processor type on which to run the pod. When you click on the drop down here, you get to choose from the different shapes. For example, pod standard E3 flex, E4 flex, and A1 flex. Also make a note, only those shapes available within your tenancy that are supported by OKE are shown in the list. In my case, all the 3 supported shapes are available. Let me select the default one, which is E3 flex. One thing to note here is that unlike the managed worker nodes, you don't get an option to select or customize your CPU and memory requirements. You must note that you have to explicitly specify the CPU and memory resource requirement for virtual nodes in the pod specification file, and we will take a look at it in the later demos. Under the Show Advanced options, you can choose to apply labels and taints. Kubernetes labels enable you to target workloads at a specific node pools by adding labels to it, whereas taints enable virtual nodes to repel pods, thereby ensuring that the pods do not run on a virtual nodes in a particular virtual node pool. It's up to you to decide whether you want to go with label or taints or both. And remember, taints feature is only available within OKE that are created using virtual nodes. We will also take a look at taints later on in the future demos. At present, let me click on add row and let's add a taint to this OKE cluster. Let me add a key and let me add a value. And let's say the effect that I wish to choose for my taint is no schedule. You get 2 options to choose from. One is no schedule and other one is no execute. Let me select no schedule. Let me quickly define the difference between no schedule and no execute effect. If you select no schedule, pods that do not tolerate this taint, that is app and front end, will not be scheduled on the node. Whereas if you go for no execute, pods are evicted from the node if it is already running on the node, and it's not scheduled onto node if it is not yet running on the node. So the difference between no schedule and no execute is that with the first one, it won't schedule a pod, but if it is already running, it won't kill it. And with no execute, it will kill the pod. Let me select no schedule and let's click on next. On the cluster review page, we can review all the information that we provided to create this cluster. For example, the cluster name, the cluster type is enhanced, of course, since we are using virtual nodes. The version of cluster that we'll be using, which is 1.27.2. We can also notice the network details, and we can also notice the node pool details, right? So it's a virtual node pool with 3 nodes in it and using the shape pod standard E3 flex. And we also have provided taints to this OKE cluster with the key as app and value front end, and the effect is no schedule. Let me click on create cluster. There you go. The cluster creation has started, which is creating all the networking resources. Let me close this page. As you can notice, the cluster is in the creating state for now. We will wait some while before the cluster goes active. All right, after a while, our cluster has been created and it has a status active. Now, in order to access the cluster, let me click on access cluster button over here and let's launch the Cloud Shell. Next step is to configure the kubeconfig file that will allow us to access the cluster using kubectl. Let me copy this command and let's just paste it in the Cloud Shell. Let me hit enter. There you go. This config has been merged into an existing kubeconfig file. And of course, the current context will be pointing to the latest addition. Let me maximize the Cloud Shell terminal. Let's clear the screen. Now that we are connected to the cluster running virtual nodes, let's quickly retrieve the nodes running on the cluster. Let me run the command kubectl get nodes. And if you notice, we have 3 virtual nodes running on the cluster in a virtual node pool. And under the roles column, you can notice that it is virtual node. It reads virtual node over here. This means we are connected to our cluster that is running virtual nodes. Since this demo is getting too long, Let me pause here and we will resume in the next demo. Thank you so much for watching. Welcome back. Let's continue from where we left off in the last demo. Now let's check whether we can create deployment resource within our Kubernetes cluster. Let me start by creating a deployment named Nginx with one pod in it running the Nginx latest image. The command that I'll be using is kubectl create deployment and the name of the deployment, which is Nginx, and the image that the pod should be running is Nginx latest image. This command will create a deployment with one pod running in it, having the container image Nginx. Let me go ahead and hit enter. It says deployment Nginx created, but let's check the pod status. The command that I'll be running is kubectl get pods. Let's hit enter. Well, if you notice, the pod is not created. It says the status is pending. Let me go ahead and describe this pod to see why is the status still pending. Let me copy the pod name. Let's hit enter. Now from the events, it says 0 of 3 nodes are available and had untolerated taint, that is app frontend. If you recollect from the cluster creation step, we had applied a taint to our cluster where we had provided the key value as app frontend. And in our inline definition to create this deployment resource, we never added a toleration for this taint, which is why this particular deployment is not getting created, or the pods are not getting scheduled because they don't have the toleration for the taint that we have applied on the Kubernetes cluster. Let me clear the screen. Now let's run an example where we have specified tolerations against the taint app frontend in our pod specification file. So let me take you to the example directory, which is cd kubernetes examples. And here, let me open up the pod specification file. From the pod spec file, you can notice the kind is specified as pod. We have given it a name, that is Nginx test. And under the spec property for containers, we have specified the name of the container, the image to be used, which is Nginx latest. Remember, like I mentioned during the demo and in the lessons as well, that when you create virtual nodes or OKE using virtual nodes, you have to specify the request and limits for the pods. If you observe closely, we have the resources property under the spec section for our containers, where we have defined the request and the limits value for memory and CPU that must be used or utilized for this particular pod. So the limits are set to 512 megabytes for memory and 2 OCPU for the CPU, whereas the request is set to 128 megabytes and the CPU is set to 1 OCPU. Further down, we have defined tolerations where the key is app operator is set to equal and the value for the key is set to front end. Remember from the cluster creation, this is the taint that we had applied to our cluster, that is app and front end. And we have defined the similar toleration for the taint which we had defined to run this pod, and the effect is set to no schedule. Let me close this file. Let's create a pod using this specification on our Kubernetes cluster. Command that I'll be using for that operation is kubectl create -f and the pod spec file name, which is virtualpod-1.yaml. Let's go ahead and hit enter. It says resource pod with the name nginx-test created. Now if I check the pod status, you can observe that the pod is in container creating state and the previous one which had no toleration is still in the pending state. Let me rerun the command. Let's wait for a while before the pod gets created. There you go. Our pod that was created using the pod specification file which had the tolerations present in it is successfully running on the Kubernetes cluster, whereas the one that we created using the inline configuration which had no tolerations is still in the pending state. Now let's try to deploy a pod with a different toleration value and see if that works. So I have another pod specification file. Let me open it for you. Now this is a pod specification file which is given a name MySQL, and in the specs section we have defined the name for the container, which is MySQL. The image that it should pull to create the pod is MySQL latest image, and of course within the resources section we have defined the request and the limit values for memory and CPU. And within the tolerations property we have defined key, operator and value. If you notice, the key remains same, that is app, but the value has changed and it's not front end, it's back end. Let's see whether applying this pod specification file on our Kubernetes cluster will help us create the MySQL pod or not. Let me close this file. Let's run the kubectl create command and provide this pod specification file as a parameter. Let me run the kubectl create command. Virtual pod 2.yaml. Let me go ahead and hit enter. Now let's check the pod status. If you notice from the output, the MySQL pod is in the pending state. That's because the tolerations which we had defined in the pod specification file do not match to the taint that we had applied in the OKE cluster. And since the tolerations don't match to the taint, the pod is not getting scheduled on any of the nodes. Let's describe the pod and see the pod event. Let me run the kubectl describe command and provide the pod name, which is MySQL. Let's hit enter. From the output, you can notice that the pod specification that we just applied has a toleration of key value, that is app and backend, with the effect as no schedule, whereas the three nodes that are running within our Kubernetes cluster have untolerated taint for the key value, which is app and frontend. And that is the reason why the MySQL pod is not finding a suitable node for it to get scheduled on. With this, we come to the end of this demo where we saw how to create an OKE cluster using quick create workflow and create virtual nodes and virtual nodes pool within. We also saw how to access an OKE cluster running virtual nodes and deploy Kubernetes resources within it. I hope you found these demos useful. See you in the next one. Thank you so much for watching. Hello and welcome to this demo on managing virtual nodes and virtual node pools in a new cluster. So let's get started. Let's go to our Kubernetes service. Let's click on the hamburger menu. Let's go to the developer services. Let's click on Kubernetes clusters. And we have our Kubernetes cluster with virtual nodes running in the OKE VN public 2 Kubernetes cluster. First thing in the demo I want to walk you through is how to add new virtual node pools to scale up the cluster. Let me select the cluster I want to modify, which is our cluster having virtual nodes. Let's scroll down, and under the resources section, we have to click on node pools. As you can notice, we can see that there is one node pool running in this Kubernetes cluster, which is labeled as pool 1, and it has 3 total worker nodes running on it. Let me click on add node pool to scale up the cluster by adding another node pool to it. Now let's enter the details for our new node pool. First thing that we'll specify is a node pool name. Let me change it to pool 2. The compartment in which we want to create the pool, that is CTD OKE. So let's leave it default. The node type that I want to add to this cluster is again virtual node. So let me go ahead and select virtual over here. And remember, we need to have these policies in place, which we already did in our previous demo. So let me proceed. Under the node count, we have to specify the number of nodes we want in this node pool. Let me reduce it to 1. And from the pod shape, we can select the different shapes that are available. This time, let me go ahead and select E4 flex shape. Let me select pod standard E4 flex. Now in the pod communication section, we have to specify the subnet for our pod communication. Remember, pods running on virtual nodes use VCN native pod networking. Let me specify the pod subnet. So let me select the virtual node subnet, which is a regional subnet. And usually it is recommended that the pod subnet and the virtual node subnet are the same. Let me select this option over here. Let's scroll down. Let's now specify subnet for our virtual node communication. From the drop down, let me select the node subnet, which is a regional subnet. And under the node placement configuration section, we can specify the availability domain and the fault domains. Let me click on the drop down. Let's select one of the availability domains. And let's select the fault domain. And you can add another row to evenly distribute your virtual nodes across different availability domains. But in our case, since I've only defined one node under our new virtual node pool, let me stick to only one availability domain and fault domain. Let me click on add. Let's see if the work request is in place for a new node pool addition. And as you notice, we have the virtual node pool create operation in progress, which means our resource pool2 is getting created and it will be attached to our OKE cluster. But this operation will take some time. So let me pause here and resume once it's created. Well, after a while, virtual node pool create operation has completed successfully. Let's go to the node pools under the resources section and see if we have our new pool available. Let me click on node pools. There you go. And as you can see, our cluster now has two virtual node pools. One is pool 1 with 3 worker nodes, and the other one that we recently added is pool 2 with 1 worker node. And just in case, like I mentioned, you can also add a managed node pool to your enhanced cluster. How do you differentiate whether a pool is a virtual node pool or a managed node pool? It's basically the node type column that defines whether it's a virtual node pool or a managed node pool. In our case, both these pools are virtual node pools, which is why it says virtual over here. To see more information about a virtual node pool, we can click on the pool name. And this takes us to the virtual node pool details page, where you get to see the virtual node pool type. It's virtual, it's ID. And the placement configuration for this virtual node pool, it says AD1, the subnet in which the virtual nodes are placed. And also the shape, that is E3 flex, which we had used for our first node pool. You can also check the labels and taints assigned to this virtual node pool. And as you can notice, the taint applied is app frontend with the effect no schedule. You can also check for the tags assigned to the pool like creator, created on, and principal type. Now, since this demo is getting too long, let me pause here and we will continue in the next demo. I hope you're liking the demo so far. See you in the next one. Thank you for watching. Welcome back. Let's resume from where we left off in the last demo. Now let's look at which virtual node pool properties we can edit. If you want to edit a virtual node pool property, let's click on the edit button. This opens up an edit virtual node pool window. And as you can notice, we can change the virtual node pool name. We can change the number of node counts in the virtual pool, as well as we can change the node placement configuration like the availability domain, fault domains. We can add another row to add different availability domain and fault domains. We can also change the subnets for our virtual node communication and pod communication. As well as we can add new labels and taints and remove the existing labels or taints. And once you change the values for these characteristics, you must click on Save Changes and these values get applied to the virtual node pool. In our case, I'm not changing anything here, so let's click on Cancel. Let's go back to our cluster details page. And let me show you how to delete a node pool. So when you click on node pools, and let's say I want to delete pool 2 that I just created. you can select the delete node pool option highlighted in red over here. Let me click on delete node pool. And you can confirm the deletion by specifying the pool name. You can also check out the advanced options. So let's click on show advanced options. Under the show advanced options, you get to specify when and how to cordon and drain worker nodes before terminating them. You can set up the eviction grace period in minutes. Basically, it is the length of time that allows to cordon and drain worker nodes before terminating them. Either we can accept the default value, which is 60 minutes, or you can specify an alternative. For example, when scaling down a node pool or changing its placement configuration, you might want to allow, let's say, 30 minutes to cordon worker nodes and drain them of their workloads. You can set this value to 30 minutes over here. You can change the value. There is another option which says force terminate after grace period. You must select this option if you want your worker nodes terminated at the end of eviction grace period, even if they have not been successfully cordoned and drained. So let me select this option for pool 2 and let's click on delete. And we'll be able to notice a new work request for pool deletion. As you can notice, the virtual node pool delete operation is in progress. And once the virtual node pool delete operation completes successfully, we won't be able to see pool 2 entry in our node pools section. Let's wait for a while before this operation completes. Well, let's click on node pools and see if the pool is deleted. As you can notice, the pool 2 status says deleting. The worker node is already deleted. It says 0 over here. And which means in some time from now, the pool 2 entry from the node pool will be deleted. In the meantime, let me show you how to list virtual nodes in a virtual node pool. If you want to list your virtual nodes in the virtual node pool, within your cluster, go to the node pools section, and within the node pool list, you can click on this link over here to go to your worker nodes. And this gives you information about your virtual nodes. It says the node state is active. The name is not being displayed, but the Kubernetes version that's running on our virtual nodes is 1.27.2. And if you want to get more information about your virtual nodes, you can click on this arrow over here. And this gives you the node ID, as well as the subnet in which they are placed, the availability domain, and the fault domain information. Alright, let's head back to our node pools and see if pool 2 is deleted. Let's click on cluster details from the breadcrumb menu. Let's go to the node pools under the resources section. And you can very well see that pool 2 entry is now gone, which means pool 2 delete operation was successful. We just saw how to scale up and scale down our Kubernetes cluster by adding new virtual node pools, and later on we also saw how to delete an existing virtual node pool. Similarly, we can scale up and scale down a virtual node pool within your OKE cluster by adding or subtracting virtual nodes from the virtual node pool. You simply have to click on edit and change the node count. Either you add additional nodes by increasing the node count, or you subtract existing worker nodes by reducing the node count. Let me quickly demo it to you, and let's scale up this virtual node pool with the name pool1 by adding one additional virtual node to it. Let me change the total count to 4 here, and let's click on save changes. As you can notice, the status of virtual node pool says updating, which means a new virtual node will get added to this pool. This can also be confirmed from this information here, as it says total virtual nodes is now 4. Let's go to the work request. And if you observe, we have the virtual node pool update operation in progress, which basically is adding additional virtual node to our virtual node pool. There you go. Virtual node pool update operation has completed successfully. And now if I go back to the cluster details page, if you go to the node pools section, the total worker nodes has increased to 4. Now let me click on the worker nodes here, and we can simply list the virtual nodes in the virtual nodes section. As you can see, the list says there are 4 worker nodes now. With this, we come to the end of this demo where we saw how to manage virtual node pools and virtual nodes in a Kubernetes cluster. I hope you found this demo useful. See you in the next one. Thank you so much for watching.